Hey everybody, welcome to Unit 2 video, or Section 2. And this video is going to talk about the structure of an atom and the parts of an atom, where you can find them, and some of the properties of an atom. So I'm hoping by the end of this video you'll be experts at all the parts of an atom. So you will see here that I have actually made, or not made, but I've found a picture of an atom. Okay, now this is not an actual picture of an atom, but this is just a representation of what an atom looks like. Okay, now one of the interesting things here is the nucleus is so small in there that you can't see it. The only thing that you can see really is the electron cloud that surrounds the atom. That's what this is. Now, in previous models, meaning in models before this model became the one that we used, one of the common ways that we think of electrons is moving in orbits, kind of like what we call the planetary model. And so even in biology, a lot of times biology teachers will just say, hey, the electrons move in these circular orbits, but that is incorrect. That doesn't take into account three-dimensional motion. So an electron, actually, if this is an electron, it could be here, could be here, could be here, could be way over here. So what you see here is a picture of that electron moving all over the place, and it's moving all over the place in 3 dimensions. So this is a spherical, like cloud-like thing, because that electron is moving very fast. And there are different colors here. This one is a little darker blue, and this one is in the middle is really dark blue, because there's more electrons in the middle, and so it's more concentrated with electrons. Okay, so if you have 10 electrons moving around here, you know, including maybe one electron that's out here that's moving all around, it's going to look darker. So this is really the picture of what an atom looks like. This is, like I said, called the electron cloud model. Now, the middle of an atom is called a nucleus. Inside the nucleus is where we have protons and where we have neutrons. Okay, protons and neutrons are the 2 subatomic particles found in the nucleus, and they're very, very small. Okay, realize that the nucleus of an atom may only be 1/3000th of the size of the radius. Okay, so the nucleus is very, very small. Okay, and then out here we have the electron cloud, and in the electron cloud we have, obviously, the electrons. Okay, so keeping in mind that all of these, whoa, hey, look at all that information. Maybe I'll delete. Looks like I should have done this beforehand. Okay, but whatevs. Okay, you get to see how this is all done. Okay, so protons, neutrons, and electrons are the 3 particles, and like I said, they are very, very small. Now, an element is a unique piece of matter. It is unique because it has different combinations of protons, neutrons, and electrons than other pieces of matter. And we should be able to know something about what makes atoms different from other atoms. Elements are defined by the number of protons that they have in them. So an element, carbon, an atom of carbon will have 6 protons in it no matter what. And that is different from an element, from an atom of nitrogen, because nitrogen has 7 protons in it, and they never be the same. If we take that atom, if we take any of those atoms and break it apart, then now they all the parts are the same. Atoms are only built out of 3 parts: protons, neutrons, and electrons. And so if they all look the same, at what point do they become different? When you have different combinations of protons, neutrons, and electrons. Okay, so everything is really small in an atom, and so when I talk about the mass of a proton, neutron, and electron, okay, we're not talking about actual mass, because let me just write this down. The actual mass of a proton is 1.67 times 10 to the minus 24. That's a minus 24 grams. Okay, and a neutron has a mass of 1.67 times 10 to the negative 24 grams. And an electron is even smaller and has a mass of 1.54, or sorry, nope, it doesn't have, not 1.54, looking at the wrong number. Okay, I'll try to erase that. Okay, 9.1 times 10 to the minus 28 grams, so it's even smaller. So what do we do? How do we deal with this? Okay, well, we don't really use those masses. What we do is we take the biggest one, which in this case is the proton or the neutron. You can look at that. Okay, the neutron is actually just slightly bigger, so that's the one we use. But we're going to set that mass. We're going to say that that is equal to 1. Now, compare the proton and the neutron mass. Compare those two masses. Are they the same? Of course they're the same. So we're going to say that this is equal to 1. And instead of giving it a unit that we normally use in the metric system, we're going to call it an AMU. An AMU stands for atomic mass unit. Okay, so a proton and a neutron have a mass of 1 AMU. We don't talk about, because they're so very tiny, it doesn't make sense to talk about it as having a mass in grams or kilograms. Okay, now, even if we kept these AMUs, it turns out that the mass of an electron would have 0.0005 AMU. Okay, that is so tiny, very tiny, and even the biggest element only typically has 100 or so electrons in it. That's the very biggest one, not even the most common ones. And so if it's the biggest element and it only has 100 or so electrons, 100 or so, that's going to be 0.05. So we're not even changing the percentage. We're not even changing the mass of an atom by very much. So what we do is we take this and we say, well, an electron weighs nothing, okay? An electron virtually weighs nothing compared to the mass of everything else. Now, I have to make sure that I say to you, it's not that an electron actually weighs nothing. You can see it has a mass and it is measurable, but it is just so very small. Okay, so we'll split that up. Okay, now the charge on these, again, charge is measured in something called coulombs or electron volts. Okay, but those again do not have any reference force. Just like these masses are so small, the actual charge on a proton, neutron, and electron are so small that, again, they don't matter. So what we do is, again, we standardize them. So without going through all of this rigmarole, I'm just going to tell you that a proton has a positive charge of +1. A neutron, you can guess by its name, is neutral, so it has a 0 charge, and an electron has a charge of -1. Okay, so I think that this part of this table is important for you to kind of have in your mind. Now, the last thing that I want to make sure that I go over here is the symbols of these subatomic particles. Okay, a proton has a symbol of P+. That is a lowercase p and a plus sign. The P comes from proton, plus comes from its charge. And the neutron is lowercase n with a 0 because it's a 0 charge. And then there are electrons. Electrons have a lowercase e with a negative charge. So now this allows you to be able to describe where and what all the subatomic particles are in an atom. Okay, so I hope this clarifies this concept for you. If you have any questions, feel free to ask.